Welcome students to today's lecture. We are going to learn about our Newton forward interpolation formula. So consider we are going to derive the formula and then do some examples on the same. So consider equally spaced mesh points. Equally spaced and mesh points. So this is what I mean. So if we have an x naught here, so we have x1, we have x2, we have x3, we have x4, we have x5, we have x6, x7, say this xp up to the last mesh point is xn. So then now, because they are equally spaced, then the distance between consecutive mesh points is the same. So this is h, this is h, this is h, 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 etc. So to get x1, we give the values of each mesh point with respect to the starting mesh point x naught, the same as x naught plus h, and then x2 is given by x naught. So you need to move two h steps 2 times. So plus 2h. x3 will be x naught plus 3h. x4 will be now, to reach here we have 1, 2, 3, 4. x naught plus 4 times h. And then as you can see, the trend continues up to the point, a general mesh point xp will be given by x naught plus ph. So therefore now, for this scenario, so so in general, any mesh point can be given as xp equals to x naught plus ph. Or simply we can just say x equals to x naught plus ph, where x is the same general xp. So xp means now it is the value of the mesh point p step from the first mesh point x naught. So then now, since we have this one now, we are interested in finding a polynomial which can help us approximate values by values of the mesh points, values of the function at each of the mesh points. So from this relation, x equals to x naught plus ph, so we can define the value of the function at this general mesh point. So therefore, the value of f of x will be the same as the value of x naught plus ph. For this is the value of x, and then this is the same expression for x. And then remember, from what you have done before on the operators, remember the shift recall that shift of f of x is given by f of x plus h. And then second shift of f of x is given by f of x plus 2h. The third shift of f of x is given by f of x plus 3h. And then in this similar manner, shift raised power n of f of x is given by f of x plus nh, or similarly saying that shift raised power p of f of x is the same as f of x plus ph. So this in a similar manner, we say that we can write this one as e fk, the same as fk plus 1, and then this one e squared of fk is the same as fk plus 2. Similarly, e power 3 of fk is the same as fk plus 3. And then e power n fk is the same as fk plus n. And then e power p of fk is the same as fk plus p. So therefore now we want now to use this relationship between the shift operators to redefine this expression here. This expression here, call it equation 1. Now, so equation 1 can be written as f of x equals to f of x plus ph, so which is the same thing as e raised power p of f of x. You can see it from this relationship here, from this point here. So I'm making use of this relation to rewrite this f of x plus ph. Also remember, the shift operator also has a relationship with the forward operator, given by that the shift operator is the same as 1 plus the forward operator. So therefore, this can be written as, where the shift operator we write 1 plus the forward operator raised power p of f of x. So therefore now, we use binomial theorem to rewrite this term here. And then just remember, maybe also from this one here. So at this point, so when we let k to be 0, so it means that then this will be given by e raised power p of f0 is the same as f0 plus p. So therefore, this we can as well say, if we call this one equation 2. So when you let this x, we measure this f of x naught. So f of x can be given by f of x naught. Remember, this should be x naught. So this is x naught. This is x naught. So f of x naught plus pH is the same as e raised power p of f naught, which is the same as 1 plus forward operator raised power p of f naught. So remember, we sometimes use this notation that f of x naught is the same as f of x. Let me just write as a gentle subscript k f x subscript k is the same as f subscript k. So that's why f of x naught can just be written as f naught. So therefore now binomial theorem gives us 1 plus forward raised power p will be given by p 1 plus p forward plus p into p minus 1 over 2 factorial second forward and then plus p into p minus 1 p minus 2 over 3 factorial third forward plus, so call this one equation 3, p into p minus 1 p minus 2 p minus 3 over 4 factorial fourth forward plus several terms up to p into p minus 1 p minus n plus 1 over n factorial n forward plus several terms. So therefore now we are trying to rewrite this part here as a series using binomial. So therefore now replacing this series in this equation 3, we have f of x will be given by 1 plus p forward plus p into p minus 1 over 2 factorial p into p minus 1 p minus 2 over 3 factorial plus p into p minus 1 p minus 2 p minus 3 over 4 factorial fourth forward plus other terms up to p into p minus 1 p minus 2 p minus n plus 1 over n factorial n forward plus other terms, and then times f naught. So therefore now f of x will be given by, now we multiply f naught by every term. So we'll have f naught plus p forward f naught plus p into p minus 1 over 2 factorial second forward of f naught plus p into p minus 1 p minus 2 over 3 factorial third forward of f naught plus other terms p into p minus 1 p minus 2 p minus n plus 1 over n factorial forward power n of f naught plus several terms. So therefore, this formula is what is called the Newton forward interpolation formula. So this is the Newton forward interpolation formula for approximating the value of the function at a gentle mesh point x or xp. Now, when when you approximate by a polynomial of degree f, degree n, by a polynomial of degree n, then we stop at the term, i.e., the formula becomes so will be now f of x equals to f naught plus p f naught plus p minus 1 over 2 factorial f naught plus p into p minus 1 p minus 2 over 3 factorial plus up to p into p minus 1 p minus 2 p minus n plus 1 over n factorial n. So we stop here. So this becomes the formula that we use. If we are trying to approximate by a polynomial of degree n, we stop at the nth difference. Point number 2, the error associated. So when you say the error, you simply mean truncation error associated with this approximation. That means that you're approximating by a polynomial of degree n is the next n plus 1 term, i.e., the truncation error is roughly, if I write this one to mean truncation error, is roughly given by the absolute value of p into p minus 1, p minus 2, up to p minus n. So remember, we need now, so n plus 1 is the last one, so then p minus n. So this becomes p minus n, the last term here. p minus n over n plus 1 factorial and the derivative of f naught. So this is approximate value of the truncation error. So which means that then if you are approximating by a polynomial of degree 3, then the error becomes the the term with the fourth difference. If you are approximating by a polynomial of degree 5, then the error becomes the next term involving the sixth difference. It is, we'll see them in examples. Let's go to the next one. So the next one is the Newton. Backward interpolation formula. So NBIF. So also consider equally spaced mesh points. So where the distance between consecutive mesh points is h. So in a similar manner, just as we have seen before, x1 will be given by x0 plus h. x2 will be given by x0 plus 2h. x3 will be given by x0 plus 3h. xp will be given by x0 plus ph. And also, so therefore, a gentle point x, which is the same as xp, is x0 plus ph. So then, as we have seen before, we are interested in defining the value of the function at this gentle mesh point. So we remember that to define f of x, which is the same as f of xp, the same thing as defining f of x naught plus p h. But remember, shift of f of x naught plus ph, f shift of f of x naught is the same as f of x naught plus h. And then the shift squared of f of x naught is the same as f of x naught plus 2h. And then the fifth shift of f of x naught is the same as f of x naught plus ph. Now, this can as well be written as shift raised power p of f naught is the same as f naught plus p, where h is taken to be 1, just as we have seen in the case 1. So therefore now we can say that now f of x naught plus ph is the same as e raised power p of f naught. So then we also remember that I recall that the relationship between the shift operator and backward difference operator is given by this. This is the relationship between the shift operator and the backward difference operator. So call this one equation 2 or equation 1. Let's just call it equation 1. Call this one 1. So which means that then the 1 can be written as f of x equals to e raised power p f naught, which is the same as 1 minus p f naught. So remember also that e raised power minus p of f naught is the same as f minus p, or the same thing as f of x naught minus ph. So that's why I have this negative here. So also we apply binomial theorem to this term, 1 minus backward raised power negative p. And then when we do that one, so 1 minus backward raised power minus p, we're given by 1, and then plus p backward plus p into p minus 1 plus 1 over 2 factorial backward square plus p into p plus 1 p plus 2 over 3 factorial backward power 3 plus other several terms. So just to see clearly how these sides are becoming positive, just remember that the normal binomial theorem, maybe some are wondering how we are making this one to be positive. Remember, by definition, if I have this is given by 1 plus nx plus n into n minus 1 over 2 factorial x squared plus n into n minus 1 n minus 2 over 3 factorial x power 3 plus n minus 1 n minus 2 n minus 3 over 4 factorial x power 4 plus other terms. So this is the definition of binomial theorem. These are, by the way, to explain how we are arriving at that answer. So let me put in red to show that, by the way. Now, if we have now 1 minus p, so remember, this can be written as 1 plus minus and then raised power minus p. So therefore, the role of x is taken by minus negative backward operator, and then the role of n is taken by minus p. So therefore, let's try to replace these values into the formula. So it means that then 1 minus backward raised power minus p will be given by, so this is 1 by definition, and then where this n we replace by minus p, where this x will replace by minus backward, and then plus where this n will replace by negative p, where this n will replace by negative p, and then minus 1, where this is over 2 factorial, and then where this x will replace by negative backward square, plus n will replace by minus p, this will replace by minus p minus 1, here will replace by minus p minus 2 over 3 factorial, and then minus backward raised power 3. So this is just a few terms to explain them. So you see clearly that this will give us 1 minus is plus, so we'll have plus p backward. So this term here, and then here this remember there's a negative here. This term can be written as, from your algebra, this is the same as minus p I can factor out minus p in this second term. So minus 1 into p and then plus 1. It's like I have minus p times minus 1 times p plus 1. So this negative and this negative cancels out. So this and this cancels out. So I remain with p into p plus 1 divided by 2 factorial. And we know that any square of any number, whether positive or negative, will always be positive. So I have backward power 2 as this term is here. And then at this point here, this is the same as minus p times, you factor out negative here. So I have negative 1 into p plus 1. I also factor out negative sign here. So times negative 1 into p plus 2. Because when I factor negative, then this will be positive sign. And then remember, this is negative forward this power 3. So when the power is odd, then the sign is negative. So it's like I have negative 1, then forward power 3. So then everything here over 3 factorial. So clearly you should be able to, you should see that. So this negative sign cancels with this negative sign. This negative sign cancels with this negative sign. So therefore the thing remains p into p plus 1 and then p plus 2 divided by 3 factorial and then backward base power 3. So that's why you have this term here. So that is how we generate all other terms for that series. So this was just, by the way, to explain why now the signs there are positive. So therefore now, therefore we have f of x will be given by now 1 plus p backward plus p into p plus 1 over 2 factorial backward square plus p into p plus 1 p plus 2 over 3 factorial backward power 3 plus p into p plus 1 into p plus 2. Now remember the last one, the n one should be p and then plus n minus 1 and then over n factorial, so plus several terms times f naught. And then on simplification, on now multiplying f naught by every term, so we'll have f of x equals to f naught plus p backward f naught plus p into p plus 1 over 2 factorial backward squared f naught plus p into p plus 1 p plus 2 over 3 factorial backward power 3 f naught plus p into p plus 1 p plus 2 p plus 1 plus n minus 1 over n factorial backward power n f naught plus other several terms. So this is what we call the Newton backward interpolation formula. So this is the Newton backward interpolation formula. In a similar way, NB, just as we have seen in the case of forward interpolation formula, when the interpolating formula is when we approximate by a polynomial of degree n, Then the formula is f of x equals to f naught plus p backward f naught plus p into p plus 1 over 2 factorial backward square f naught plus p into p plus 1 p plus 2 over 3 factorial backward power 3 f naught plus other several terms plus p into p plus 1 p plus 2 p plus n minus 1 over n factorial backward power n of f naught. And then the error associated with this approximation will be the next n plus 1 term. The error, the truncation error, associated with this approximation is the next n plus 1 term, i.e., the truncation error is approximated by p into p plus 1, p plus 2, divided by, so p plus n So these are the value of the truncation error. So that's the end of the derivation of the two formulas, Newton forward and Newton backward interpolation formulas. So in the next lesson, we'll be able to give examples on how to apply them. Thank you.